Right then, let's get started, shall we? Right, let's see. I got my days all mixed up because I'd streamed on Saturday, didn't I? So, Monday, I set some homework after we'd learnt how to use buttons and stuff. And it was to do a Pelican Crossing, a UK Pelican Crossing. Now, I have had some submissions in the homework folder. So let's start with Mr. GaryMeg, shall we? Can't see there. Right. So this is Monsignor GaryMeg. So he's gone all out on the arrays and the loops. Oh, I didn't think it settled. So yeah, so he's got out with the. So this is the setup, and then the loop is just looping round the light sequence. Others are doing their homework. They're a bit late. Hello SP, welcome. So he's got a test for. Hello Mikroman, welcome. So he's got a weighting test, which then he does the cross. Oh right, so that initiates the crossing. Jasmine ate your homework, made him sick because it was C. Oh well, never mind. Right, let's play this. Let's see what it's like. So, we have got two sets of lights. And so we press the button. We get the indicator that says the button's been pressed. And he had to be clever. He had to be clever. Put a beeper in it. But it's not a Pelican Crossing. Oh, Nico, out. Out. Come on, out. Go on, over there. In your bed. Go on. In your bed. Come on, mate. Go into your bed. I've bought them heaters as well for the beds to keep them warm. Right, so, but this is not a Pelican Crossing. So, yeah. Right, next one. SP, here we go. SP, more of the same. More of the same. I do like how you've made this so array sizes doesn't restrict you in any way. But basically, setting up the pins, right, so that's the traffic light pins, the pedestrian pins, setting up the button. No. Traffic light pins, pedestrian pins. Oh, the button pin. Okay. Setting up the button. And then initiating the setting up the lights on the first sequence. Right, let's run it. Let's get that out of the way. So press the button, light comes on, It works. It works. But yet again, not a pelican crossing. Not a pelican crossing. Ugh. It's not a pelican crossing, but you're close. But it's not quite there. Not quite there. But it does work. Right. Let me show you what I mean by not pelican crossing. Oh, Nico. You're alright, mate. Here we go. Yours was perfect, but Jasmine. Hang on a second. He's not been happy today. He's not been happy today. Yes, Gary, we've looked at yours, but it's not a pelican crossing, mate. It's not a pelican crossing. This is a pelican crossing. This is a pelican crossing, right? So let me just run it and I'll show you what I mean. Right? A pelican crossing is a set of traffic lights that allows a person to cross the road, right? So the traffic light is always on green. It's letting the traffic go through. It's always on green. Always. Always. Until a user wants to cross the road. And then you press the button. So you get the light that says please wait. Then you get a delay as the traffic lights then go to yellow and then to red. Then the pelican crossing goes to green. And then flashes green while the amber light flashes and then goes to green. So that is a pelican crossing. And if you look here, let me get it on here. Oops, no, wrong one. That one. Here, after 2 hours of pulling my hair out, got it working. So we press the button. The light goes on to say, please wait. The traffic lights then change to stop the traffic. We now go to green on the LED. And then when it's about to finish, it goes to amber on the traffic light and flashes green on the pedestrian light. And then goes to green and red on. That is a pelican crossing. That is a pelican crossing. Now, I think Gary got a bit carried away. Because you did I think it's a puffin crossing on a junction. I think what you did, Gary, was a puffin crossing on a junction. Yeah? And SP, it was sort of... I'm not sure what SP's one because there was only one set of traffic lights, yeah? But they both worked. They both worked. You pressed the button, it interrupted the cycle, went through the pedestrian cycle, and then re-established the traffic cycle. So they still worked. They still worked. The only problem was they weren't pelican crossings. And I did try to hint. I did try to hint. SP was the road works on my street. Yes, the beeper worked okay, mate. That's what I'm saying. I think you got a bit carried away. You got a bit carried away. But yeah, I think yours is more of a puffin crossing, which is on an intersection. Yeah, where you've got the intersection you got the two set of traffic lights on the intersection, and then you press the button, because then it does go green, amber, red, amber, green, blah 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 blah, and then it stops all the traffic as then the pedestrians can go off. But then it doesn't have the flashing light. It doesn't have the flashing light on a puffin crossing. It only goes from red, amber, then green. There is no flashing amber on a puffin crossing on a junction. Only the Pelican crossing has the flashing amber. Right? That's all. That's the only one that has the flashing amber, because the Toucan crossing doesn't have the flashing amber, and the equestrian crossing doesn't have the flashing amber. Alright? So well done, guys. You did get it working. But what we need to do now is to do what I've done in here. Right? Because I need to Google the 1970s public. Well, I didn't Google. I've actually got it here. Right? I've actually got it here. A YouTube video about all the... Oh, get rid of that. Let's turn that off. Come on. A YouTube video about all the different types of crossings. Right? The traditional Pelican crossing. This is the traditional Pelican crossing. Right? And so that's how I did my research. So there is a YouTube video out there about all the different crossings. Teacher needs to be more specific and says he wants flashing lights. I said what type of crossing. Anyway, it doesn't matter. It doesn't matter. But what I do want to see now is functions. I want to start seeing functions in the code. Right? Now, if you don't know how a function works, it's a way of writing one bit of code that could be called many times. And there's two ways. Just claim you're not English. Oh dear. Right. So I found a YouTube video about it, and you can search it. Right. So I want you to start using functions. Now, for the people who've been doing it and don't know what a function is Evening Docster it's a piece of code that you can call many times, yeah? And you don't have to repeat the code. So I've created some functions. So I've got one that says set to output, and you put the pin number in there. I've got one to say set to pull up, and you put the pin number that sets it to pull up. And there's two different types of functions. There's one that you just call and it just does something, and there's one that you call and it returns a value. And I've got one here called read state of pin. Yeah, read state pin. Now, the difference between the ones that can call and just does something is you put the word void in. It means I'm not gonna return anything. John, wait till day 5. It is about functions. Oh, is it? Oh, is it? Right then. Okay. I haven't looked at day 5 yet. I haven't looked at day 5. Well, if it's all about functions, then we'll go straight into it. Right. So let me create a new project. So let's save a copy. Let's rename this to day 5 activity 1. Oh no, day 5. Day 5. There we go. Day 5. And we'll rename this. We'll rename this to day 5 activity 1. Right. So I haven't seen Can you include files? Apparently you can, right? Apparently you can. I've got to try it out, all right? I've got to try it out. I've got to try it out. Right. So, day 5. Let's find out what day 5 is all about, because I haven't seen it. So, day 5. Hear my code. So, I reckon we are looking at, yes, the buzzer. So, day 5. We have a buzzer in day 5. Nice. Right, let's turn that thing off at the bottom. Right. So we're going to be making noises. Nice. Right, today we'll be using the buzzer in a few different ways. First, for simple beeps and tones, then combining with our potentiometer to control the volume. Then finally, mute button on standby. Then finally, something a little bit more advanced where we use different frequencies to generate festive tunes. Okay. This particular buzzer works with the PWM signal, which we learnt from the previous day, to allow you to generate different tones. We'll be tapping back into everything we've learnt in yesterday's box. Right, so the circuit. Remember to unplug the Pico from the USB port. Yeah, well, let me turn it off. There we go. We'll be using the potentiometer from yesterday's box. Oh, maybe I should have copied yesterday's thing, but never mind. This will be easier. Wimp. We call it a wimp. Oh. Mikroman. Right. Simply push the red wire into GPO 13 and the ground. Okay, so activity 1. Right. Let me move that over there. So, activity 1. So we're getting, so I'm going to lose all this lot, all right? Lose all this lot. Oh, get off. There we go. Right. Right, so add buzzer. Buzzer! There we go. So we're going to add it. So the red wire goes to GPIO 13. So the red wire goes to 13. Right, so the other one must go to the one next to it, ground. Okay. That was easy enough done, wasn't it? Right. On the buzzer, we generate different tones, blah, using the based on the PWM frequency. Yeah, we've been through there. So the frequencies change between 10 and 10,000. The duty cycle, yeah. Now you want to know the value of the PWM. Okay, quick example. The example below includes the same ingredients that you were. Did you hear that? Hang on a sec. I don't know what's going on with him. I don't know what's going on with him. He's been acting strange all day. Right. So the example below includes the same ingredients you've become familiar with, import setup, blah, blah, blah. Right. So buzzer equals. So basically it's the tone, isn't it? It's the tone. Where's our reference? Oh, it's there. It's this. Pin frequency. So that's what we're setting. Okay. So, let's see. Right. So it's the tone. So let's put another. We'll get rid of that. We'll get rid of all this lot. We need the setup in there. Hang on. Stay there, stay there, stay there, stay in your bed. Careful, stay in your bed, right? Stay in your bed. If you want to be here, stay there. Right. The green wire's connected to the speaker, look. Because look, it moves with it. There we go. We'll move it out of the way. We'll move it. Nico, I brought you in here so you could... Come on, get in your bed. I brought the bed in here for you. No, 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 no. Not underneath the chair. Come on. Not underneath the chair. In your bed. In your bed. Come on. Stay there. Oh, I don't know what's up with him today. Right. So, where's the code? He's on new pain meds, so I don't know if that's what's causing him discomfort, because he's on new pain meds. Right, so we're using the tone. So let's do this. Tone, buzzer, comma. Now they're doing a frequency of 1000, so we'll do the same thing. Then we're going to delay for a second. And then we are putting 0 in it. Right, let's see if this works. There we go. That was easy. Now try changing the frequency number to 300 and see what happens. Okay. 300. It went doo. Right, did we get a lower tone? Yes, we did. You can try higher values too. Eventually you'll get too high, around 10,000, and you won't hear it because humans can't hear it. Right, okay. Let's try it. 9,000. Yeah. Okay. Let's see if the boys can hear it. Well, I heard that. I don't know about anybody else. Did anybody else hear that? Yeah, it was high. Right, let's try that. Well, I didn't hear that. Well, I didn't hear that anyway. Yes, it's a simulation, yeah. Nico. He's going to hurt himself. What's the matter? I brought your bed in here. Come on, get in your bed. Get in your bed. Get in your bed, buddy. Get in your bed. I brought your bed in here so you could be next to it. Yeah? Yeah, that was too high. Right. So that's activity 1. Alright, so we've managed to get it to make noises. Right, activity 2. Changing tones. Here's another simple example just to show you how easy it is to change the tone on your buzzer from one to another. Let's start with a frequency of 1000 for 1 second and then drop it to 500 for a second. Okay. Right, let's do a copy of this. Let's rename it. Create a new file. Activity 2. Right, we'll do a copy and paste. This is where you get to slap. Yeah. Oh. Go on, Nico, get in your bed. I also figured out that if you don't do this, the simulator has a problem. It drops down to like 20%. Look, can you see it's on 34? But if I recycle this now, so it's now going to compile it with that delay in. Look, it goes to 100%, look. It doesn't like having no code in the loop. Yeah, it doesn't like having no code in this loop. Doesn't like it at all. The simulator doesn't like it at all. Right. So let's do what it says. So we're saying 1000 for 1000 for 1 second, and then 500 for another second, and then switch it off. Right, okay. So we should get 2 tones. What's the matter, buddy? What's the matter? Come here. Come here. Say hello. Go on, say hello, just in case you want to say hello. Yeah? You're going to say hello, look. You're not a happy bunny today, are you? You've not been a happy bunny today, have you? Hmm? Well, at least you're not trembling now. Eh? Hmm? See, everybody's saying hi. Everybody's saying hi. Hmm? You're going, who's saying hi? Aren't you? Hmm? All them people, all them, up there. Up there, up there. Yeah, that's it. Look up there. You can't see much, can you? Alright. Right, I'm going to put you in your bed, alright? Come on then, let's put you in your bed. Stay there. You keep thinking of a puppet. Few more lines of code and we'd have a SID player. Well, yeah, it could do. Right, so that's activity 2. So the right, okay, volume control. Right, let's do this. Let's do this. I would do it on the hardware, but it would takes me so long to set it up. I mean, this GaryMeg will tell you. I was pulling my hair out earlier, because, and let me show you this. Because, see the breadboard? Yeah, see the breadboard? Apparently, there's a manual for the breadboard, right? There's a manual for the breadboard, yeah? And I didn't read it. But apparently, because there's a gap just there in the lines, it means that if you put a ground or power connection in here, it doesn't come across here. So, I add the ground and the power connection on here, but I've put the LEDs on this side. And I wasn't getting any LEDs. I wasn't getting anything. Couldn't understand why I couldn't get any for 2 hours. And I was ranting to Gary for 2 hours. And then he goes, "Have you got a break in your line?" And at that very moment, as he was saying it, I'd read about the breadboards. I was reading because I was thinking, there can't be a manual for the breadboard, but there is. And if there's a gap in the lines, it means the connection is broken. And there's a gap in the line. So yes, it was 2 hours of my life I won't get back. 2 hours. But hey ho, these things are set to testers. I now know what to look for in future when things don't work. Have I got a cable zipping across? Oh, absolute rubbish. Absolute rubbish. I did wonder. He's finally settled down. Yes, we live and learn. We live and learn. He's finally settled. He's finally settled down. He's finally settled down. So we'll see what he's like. We'll see what he's like. Yes, we'll live and learn. Well, I've learned something new. I thought the breadboard was connected all the way across. Didn't even read the manual because I thought, well, I know about the lines going down and I know the 2 rails, but I thought it went across all the way across, but nah. Right, so what we're going to do, let's use one of the previous components to control the volume of the buzzer. This one gets a bit noisy and not perfect. The sound can distort or cut out at eye levels, but it's for fun project to try out. If you find the buzzer a bit loud and harsh, you can always place some sticky tape or a blob of blue tack over the hole. Do you guys know what blue tack is? Oh, or even sticky tape. Right, the readings of the potentiometer, we already know this. In the example below, in each while loop we are... You're not putting sticky tape over your hole. Copyright it. What it is. Yeah, unfortunately, I think it's already copyrighted, I think. Right, okay, so in the example below, in each while loop, we are taking the reading from the potentiometer and storing it in a variable called reading, yes, as activity 3 yesterday. Right, I've got activity 3. Well, I've got all the activities all in a what's it here. So day 4, activity 3. There it is. Good luck with volume. Really? Okay. Oh, is this where it doesn't work? Is this where it does, where you had the problem and it didn't work? Arduino volume control library. Can't control duty cycle without playing with the dimmers, the timers. All right. So this doesn't work in C++ then? This doesn't work in C? Where's the code? Isn't there a GitHub? Oh, here we go. Right. So where's the volume H? Where's the volume H? Is that part of Is that part of the Arduino set then, volume H? Oh, he's up. He's up. He's really restless today. So where do we get volume H from? Aha. Hey, Nikomo. Volume 1. Okay. And what's this then? Is this only for the Arduino, not for... I've not learnt about libraries yet. But this will only work on the Arduino, won't it? Hang on, guys. I'm going to take him out just in case he needs to go. I won't be a second. I'll leave this on for you. It will work on a Pico. Okay. Well, let's try it then. Right. Oh, Nico, come on. Nico Pico. God, that's going to get confusing, isn't it? Nico, come on. No. Not underneath the chair. Come on. Get in your bed. Come on. You've been out. Right. Let's see. Let's see if this will work. Save. New file, volume .cpp. Yeah, is that how you spell volume? Volume? Right, let's paste that in there. Right, so we need to create another one called volume.h. So volume.h. All right. Let's grab that as well. So this H file is like an interface, isn't it, in C#? You're correcting my spelling. A C header file. Yeah, that's like an interface file in C#, isn't it? It looks like it. Where it just describes what it is. Right, okay, so let's see. Where is the example? Here we go, example. So, test warble. Let's see what that does. So, So we include this. Alright, let's try that. So include that. And oh, header files define public routines, not private ones as well. Right, okay. Okay. Right, so we need to create a global thing for that. So volume is a vol is type volume, and setup. So we need to put this in the startup. So let's do that there. You've been out, mate, and you did something, and you've had a drink. So it's what we can call copy the whole lot. Oh, just to try it out. Okay, we'll copy the whole lot. Okay. Right. Save it. Let's try it. Let's just see if this works. Yeah. Oh, what's underscore speaker is not declared in this scope. What have I missed? Activity 3. Go. What's it throwing? Volume. Oh. Check my pin numbers. Hang on, hang on. What's the matter, mate? What's the matter? Come here. What's the matter? Hey? What's the matter? What's the matter? You can still see, mate, because you saw me move the phone. What's up? Hey, what's up? What's up? Hey? Did I include the file? Yeah, I've included it here. And we got the CPP here, but it's complaining about this underscore speaker. It doesn't know what the underscore speaker is. Whoops. Oh, so underscore speaker won't be on because we don't know what this is, do we? What is that? Yeah. So it just says it's a buzzer, that's it. Okay, so our speaker is on pin 13, isn't it? Yeah. Which is this. So we'll do this. Right, let's see if that. Save. No, it doesn't like it. 39. You better not fall off, mate. You better not fall off, alright? Right, sit there, alright? Don't fall off, alright? Or I'll have the entire community shouting at me. Mate, come on. Stay put, yeah? Stay put. Lie down. You're trying to help me debug this, yeah? You see, it doesn't like it. It does not like it. Right, we'll give up on that activity. We'll give up on that activity. Right, so we'll give up on that. We'll give up on that activity because it's Morph Cat. All right, come on. There we go. Hello Raiders. Hello. I haven't got a defend button. I haven't got a defend button. Welcome to our little corner of the internet. Right, so we're going to abandon activity 3. So let's rename the files. Because we can't do the volume in the simulator. We'll probably be able to do it. Oh, we can't do it in. Let's put it this way: we can't do it in C++. Be able to do it in Python, I bet. Right, go on that one. Let's rename that so it doesn't get confused. And rename that so it doesn't get confused. Right, so we will ignore the volume. We will ignore activity 3 because we can't do it. Hey Prodonfig, welcome. Hello Raiders. How are you doing? It's not very often I get raided. It's not very often. Right, okay. So we'll do activity 4. Let's do activity 4. Right, new file. Oh, I don't like it when it does that. There we go. Well, I normally do retro. Normally code a 6502 machines, or the Commodore ones, really. But we're messing around with a Pico. We're messing around with one of these fellas, right? Because there's an advent calendar out, so we're going through the days. But normally we do 6502 coding. But we're just having a bit of fun with C and how to program a Pico and make it work. So we're going through all the tutorials that's currently out there at the moment. So yeah, we do C64 stuff. We've recently wrote a game that features both my dogs. There's one there. It features him. Who's staring me out at the moment, right? Who's staring me out. You code for the NES? Yes, I've been looking at doing that. Right, so activity 5. So what we're doing? Oh, this is a big one. Right, let's grab this. Use that as our base point. Yeah, Proton Fig streams C64 stuff most days. Yeah, I got the code, mate. I've got the code. Let's see what it's doing. Right, so we're going to have a little bit of festive fun with our buzzer. By changing the frequency between each pause, we can create a tune that resembles a popular festive tune. All right then. So let's do them. So let's do them. Now this is in MicroPython and we are changing it to C. Now I have been given the code already. Someone spent the time coding it up. Here it is. So we're going to copy this because I don't want to bore you guys. We're trying to type it in and it goes in there, yeah. So basically, if we look here, so ignore the volume. We're just doing the same thing. So we are, and I need to do. Oi, John, pay attention to chat. Hang on. Remove the equals. Yes, yes. Right, so I need to. Would Control F work? Oh, yes, it does. Nicely, nicely. Right, replace that. Done them all. This is VS Code. I don't know if you've noticed. This is... Alright, Proton Fig, we'll see you later. This is VS Code. A simplified version of VS Code, this editor. It's got to be. It looks like it. Right, so... You love VS Code. I know you do, mate. I know you do. Right, let's tab that across. Right, so we're doing right. So let's just check. So E for 100, 0 for 200, E for 100, 0 for 200, E for 100, 0 for 200. Oh, 500. Right, okay. Press F1 and type format. Look, it's VS Code, look. It's VS Code. Why isn't there an extension then? Why is there not an extension in VS Code that we could run inside VS Code? Never mind. Right, here we go. Let's hear what this has got to say. And there you have it. all that. We could make this better. We could make this better. Oh, my coding brain's going, no, we've got to make this better. Fun times. Where's the rest? I don't know. So that was activity 4. What's activity 4? Oh, using... Oh, right, here we go. Festive jingle using... Oh, here we go. That's where thing was... Gary was talking about... Stop talking about functions. They're going to talk about it. Right, okay. Right, let's create the next activity. Day 5, activity 5. Right, let's grab this lot just in case we're going to use this. It's almost a SID. We're moving forward towards the SID player. Yeah. Yeah. Right, okay, so we're talking functions. Right, I tried to explain this, but Gary quite rightly went and said stop it because they're going to talk about it. Right, so let's improve the very long code from above to introduce something new called a function. Functions are blocks of code that you can create and then call or use at any time in the program. They're great for repetitive blocks of code, which this example is. And it keeps your program short and efficient. I'm not too sure about efficient. It keeps it short, but you can write inefficient code in a function. Which can be more important if microcontrollers has limited storage. Right. Let's try and explain how functions work before we move on. To write a function, below is an example of a simple function that prints 3 lines. We create a function by writing def. Oh, we're in Python. I forgot then. We're in MicroPython. All right. I'd forgotten. Where we call it my function, the add brackets yes, I can't say that one. I do write in a fish. Just because I've never won a Shalom coding contest. So what? I'm too structured. Right, this is MicroPython. So with MicroPython, you'd put def, the function name, and then the parameter list. Yeah. Parentheses. Thank you, SP. Open bracket. Close bracket. Oh. You was the first loser. Oh, you did better than I did, mate. Right, so, and then you would call the function. Yeah, open bracket, close bracket. That's what we're doing. So, in this case, in our case, in C case, we don't do def, function name, because there's 2 types of functions, yeah? There's the static function, there's the, I won't say static function. There's the function that you just run and it just does something, or there's a function that you run and it returns an answer, right? So let's have a look at the code. So they've so they've got a thing called play tone. Right now, Monsignor GaryMeg has gone and done this already, but I'll do it to start with. So we need to create a function called play tone. Yeah. Right. Let's just make that smaller. Right. So because the function here is not returning anything, it's just doing something, right? You put the word void in, yeah? That tells the compiler we're not returning anything, right? This is a function that we're just going to run. If you did int yeah, that is saying that this function is going to return an integer, yeah? Or if you did this, that's saying that the function's going to return a Boolean value, and so on and so forth, yeah? But we are not going to return anything, so we say void. And then with C, we have to do that. So what we're doing, so we're putting note, we're ignoring volume, delay 1 and delay 2. So integer note, integer delay 1, and then integer delay 2. So this function, which we are going, I think it was called play tone, wasn't it? Play tone. This function is going to take 3 parameters in, right? All of type integer. One is the note or the frequency, yeah. The other one is the delay, first delay and second delay. So let's see what they're doing in there. Right. So first things first. Tone, open bracket, buzzer, because we need to tell it which pin number, and its note. So that's the first one. Then I suppose it's delay, open bracket, delay 1. What else are they doing? Oh, setting it to 0. So tone, buzzer, comma 0. And then delay 2. Where this is where John creates the unentertainer. Best mentioned scope. Yes. Okay. So what GaryMeg's on about scope is note, delay 1 and delay 2 are only available within these 2 brackets. They are not available outside of this function. You cannot reference note inside this function. It's only inside, and so the variables have a scope within the function. All right, let's add ADSR cycle. Oh no. No. Right, so we've created the play tone function now, which means now they are playing them like this. Now, Gary, quite being the gentleman, has already done this for us. So I'm going to... Here we go. So I'm going to grab everything he's put in here. And we are going to put it in there. Let's get it indented. So what this is doing now, it's saying we're going to run the function playtone with E for 100 and then 200. Right? So we're sending in the note, then 100 millicycles. It's so the note's going to play for 100 milliseconds, and then it's going to be no note for 200 milliseconds, right? So we should end up with the same tune as we had before. Oh, hang on. I know what that problem is. It's case sensitive, isn't it? You did get it even shorter using array. Yes, I mean that's where we do. Okay. Oh, buzzer. Oh dear, there's some funny noises coming out of Nico today. Right. There you go. So it does the same thing. It would have been easier to rename that, yes, but that my OCD would have kicked in then because it always variables, functions, anything always start with a small letter to start with, and then a capital letter for your words. Yeah. So play tone. I mean, I used to do it the other way where it was capitalized everything. Is that the Hungarian way? I can't remember. And this is the... I must love your code. Yes, mate. Your code is very... how can I put this? Let's find it, shall we? Let's find it. Your code is very... This is camel case, yeah. So yeah, this makes the voice in my back of the head going, what? I mean, it's a mixture of all sorts, isn't it? It's a mixture of all sorts. I mean, we've got C64 in there. We've got single letter variables. And then we've got all sorts of... But it takes all sorts. It takes all sorts. I've always said if everybody did the same thing, it'd be a very boring place. So this is camel case, is it? This is camel case. I can't remember. So I know. Yeah, okay, camel case. But this is what I've been drilled into since I started C sharp and all that. Right. Oh, Nico, what is going on? Right. So that is day 5, I do believe. Is that the end of it? Day 5 is complete. So now we know how to use the buzzer. Excellent. This is snake case. Is it? Just not using the potentiometer, yeah. I mean, we could write write it in Python, to be honest. We could try this out in Python. It's activity 3, isn't it? So if I rename this to .py, yeah, and then get rid of all this lot, put that in, save it, then we'd need, right, we need to put in the buzzers. So 27, we need to add the potentiometer in, don't we? Where should we put it? 27's down here, isn't it? Whoa! There are some funny noises coming out of Nico. I'll ring the vet up tomorrow. See how he is. This is Chaos Case. Chaos Case. Right. Okay. So we need power to go in there. We need ground to go in there. Let's do this. Do this properly. And now 27 is there. That goes in there. Now we'll make this a different colour. We'll make it blue. Right, so that's the potentiometer on 27. Buzzers on 3. Right, so this... Whoa! What? No. No. Maybe it doesn't like mixing two different languages in the same... I thought because we had PY in it, it would do it. Oh, hang on. Need to rename that, don't we? Oh, right, okay. So we need to create a MicroPython. It's a different type of project. All right, then. Let's create another project. New project. MicroPython on the Raspberry Pi. Yeah, I was just about to do that, mate. Day 5. No, wrong day, John. Wrong day. Aston, mate, are you going to start giving me grief now? Hey? You going to start giving me grief now? Really? Right then, so this should work. Simulator doesn't like it. Yeah, it didn't like it before, did it? But we'll save it. We'll We'll put it away. So this is day 5. Activity 3 Python. Just to make sure that we know it's different. Hang on, guys. Are you wanting to go out? Alright then. Let me just take his lordship out. I won't be a second. John wanted to wake up all the sleeping viewers. Headphones really killing me. Sorry. Well, I've turned it down now, but it doesn't work anyway. So we'd have to do it for real on this. We'd have to do it for real to try it out. Right, well that was day 5, alright? That was day 5. So, have I got day 5 still out? Yes. So that was day 5. So we used learning about the buzzer. Right, so what was day 6? Oh, day 7. I think... Oh, we are on day 7. Alright. So day 6. So what's day 6 all about? Right, let's get ourselves all sorted out. So let's go back to day 5. Day 5. Let's clone this. Call it day 6. Right. So I'll leave that there, and we'll see what we're doing on 6. So, day 6, looking for light. Alright, so, welcome to day 6. Today we are going to use the light sensor. Oh, nice! Which, you guessed it, can detect the amount of light around you and provides us with a reading value. Which, how is that going to work on the simulator? Oh, we'll find out in a minute. Which provides us with a reading value that we can code. The light sensor we are using is another analog component, which means it's able to produce a range of values. Shine a torch at the monitor. Oh dear. Yeah. Change the theme to dark mode. Oh yeah. Yeah, we could do. Right, so in the box we have a 10k resistor, a photo transistor. Oh, photo transistor and the jumpers. Well, I'm not getting the box out. So today we'll be learning how to make analog readings from the light sensor. Right, do we have a photo transistor in here? Is it that? Is it that? Is that it? No, that's not it. So it looks like we can't do it. Looks like we can't do it because hang on, is that it? That's not it. Oh, someone trying to change the background. Yeah. Sorry mate, I put cooldowns in it. So we can't do this. We can't do this. Oh, you've put it in dark mode. All right, okay. Yes, it is. So we can't do this in the simulator because there is not a light, a photo trans, whatever it was called. No. Why has your resub not popped up? Yeah, it's basically okay. It's basically this that reacts to light. Yeah. I mean, we could do it on there. I'd have to encode it for real. So yeah, we could do it because essentially I've got the LEDs on there. Right. So essentially I've got the LEDs there. So Hi
John here. Another subscriber. Stay a while. Stay forever.
Gary! Oh, why does that come up twice? There we go. Gary, 11 months. You've subscribed for 11 months. Currently on a 6-month streak. Thank you for subscribing, mate. Right. Right. So this is the this was the Pelican Crossing, yeah, in real life. Gary's lagged by 11 months. So this was the Pelican Crossing. So we're going to take this apart, yeah, and we'll do the proper transducer, proper. So let's get rid of the cables. Put them there. Get rid of them. Put them there. LEDs, buttons, and little jumpers. Right. Let's get the bell out, which was day 5. So there's the bell. I should say the buzzer. And we're on day 6. And there's the transducer. Or transistor, or whatever it's called. I don't know. Put them on there, like so. Right. To try and make my workspace a little bit tidier, let's put these LEDs away. Oh, there's some strange noises coming out of Nico. He's don't know what's. I need to get some more of these because I've got so many bits now. So many bits. Button was day 2, wasn't it? Button was day 2. No. Button wasn't day 2, it was day 3. Day 3. Yep, there's the buttons. Put them in there. Right. Okay, so, oh, what have I just pulled over? That's Nico, that is. Night night, Mikroman. See you later. You'd thought he'd buy 12 calendars so he could have them ready. No! Right. So, black. What's that? 3rd pin in. 1, 2, 3. Then in that one. Right, so that's the speaker. The buzzer. Right, what are we doing now? So Let's have a look. We got a long leg and a short leg. Before you start with a circuit, you need to pay close attention to the legs of the light sensor. If you are wiring it wrong, your light readings won't make any sense. With this in mind, grab your mini breadboard. We're not using the mini one. Fit the sensor with the long leg to the left. Right, so it'll be your left. So we'll fit it there. God, there's some noises coming out of Nico. So long leg is towards the LEDs. There you go. Then put the resistor, I presume any old way will do it, between the short leg oh right, I know I'm being tracked, go away. Connect the short leg, which is that one, to the 3 volt pin. Right, so the short leg is that one. Right, let's move these about. Right, so 3 volts short leg to the 3 volt, which is that one. Get in there. Which is that one. The long leg goes to 26. Okay, the long leg, which is that one, goes to 26. How do we know which is 26? 1, 2, 3, 4, 5, 6, 7, 8, 9 on the 10th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's that one there. Right, yeah. Add the resistor to connect to the long leg. Right, okay. Resistor to the long leg. And to the ground. Okay, so we'll do that then. To the ground. Like so. Right. the one between 25 and 26. I've just wired this up and I've got wires. Oh, I had wires. I didn't need to use mine. Oh, it's too late now. Too late now. Right. That's it. That's it. Right. So let's code this thing up. So we are on day 6. Day 6, activity 1. Right. So it's basic. It's how am I going to print this out? How am I going to print this out? Where did I do the prints? There. The serial debugger. The serial debugger, yeah? But the serial debugger doesn't work. It doesn't work for me. Right, let me show you. Let me reset this. There we go. If I send this, right, now the serial debugger's here, isn't it? That. Right, so I've opened it up. So I'm waiting for it to upload. Well, I've got it open, mate, so it's still loading. Now, have I... Right, it's uploaded. It doesn't come up. Let's try this again. I don't know what's going on with Nico. I'll have to ring the vets tomorrow. Oh, reset the Pico. Right, okay. I'll try that. Right. So, serial monitor. So I've opened the serial monitor, right? So let's reset the Pico. Whoops, turn the light off. I've turned the light off. Wrong one. Right, here we go. Restart it. Alright then. So I've opened the serial monitor and then I turn it on. Yeah. Nothing. Doesn't work for me. Doesn't work for me. Doesn't work. Why won't that open? So what? Am I in bootloader mode? No. It says it's on COM 3. Is that why? Oh. Oh. Hang on. What's the matter, buddy? Whoa, 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 whoa. Come here, come here, come here, come here. Come here, come here. Come here. Come on. Come on. There we go. There we go. You're right now. Yeah? You're right. Alright then, sit on Daddy's lap. Yeah? You can tell me what I'm doing wrong, yeah? Sit on Daddy's lap. Stay there. Has that uploaded? Come on. Right. Let's do this again, yeah? Sit on Daddy's lap. Don't move about, yeah? Alright. So where's the serial monitor on this? Ah, there. I've just done that, mate. Hang on, I'll do it again. It's very difficult now. I've got a young... Whoa, whoa, whoa. Stay there. So this is a serial monitor. So I'm going to upload, yeah? As you can see, I'm not having much fun. It doesn't seem to want to. It doesn't like me. Whoa, whoa. Oh, mate, you can try and stay there. Right, come on. If you're going to move about, There you go. Yeah, you can't hear the computer doing bonk because I've turned the sound down. Hang on, let me turn the sound back up. Right? Right. Now you've just heard the go boom boom boom. Right, that's now in bootloader mode. Yeah, upload, here we go. There you go, there's the bong. It says it's been uploaded. Nothing. I'm having lots. I can't get the serial monitor to work, to be honest. I've not been able to get it to work at all. That's why I've not been using it. I don't know why. Hook up the LCD from day 12. Hang on, guys. What's the matter? What's the matter? Right. I'm sorry about this. Let me just sort Nico out. I don't know what's going on. I don't know if he needs a drink. Come on, let's take you for a drink. Won't be a sec. Come here. Come here. Let's take you for a drink. I'm back. So as you can see, I can't debug the Pico because it won't let me use the serial monitor. I don't know why. So I don't know. Remove line 1. Well, 15200 board. 50, yeah, it's the right board rate. Remove the 1. Is that it? You joking me? Oh, you are joking me. So that's what's wrong here then, yeah? Alright, let's shut that down. Let's restart it. Let's try it from here. So it says we're on COM 3, right, upload. Oh, you are joking. All this time. All this time. Ah. There you go, mate. There you go, mate. You deserve that. That was... For 2 days I've avoided messing around with the board because I couldn't figure out what was going on with it, so I used the simulator. Right, okay, seeing as that we've figured it out, seeing as that we've figured it out, we can get back on to doing this. Right. So this is effectively doing what we did in day 4, wasn't it? On the potentiometer, this. So let's grab that. Yeah, where was serial 1 printing to? and minus 50 for being late. And not doing his homework. He didn't do his homework. So, should I take some point off for not doing homework? To be honest, I didn't add any points on for the homework that people did. Hang on. So Gary did 2 Gary did 2 homeworks, but got one of them wrong, even though it still worked. So 10 points for each homework, minus 5 for getting it wrong. That's 15. We had SP, two homeworks, and he almost got the second one right. Almost. So I won't deduct him too many points because he got it very close. So let's say 17 for SP. And Kebab gets 10 because he did the first homework, but he didn't do the second. So you use C++ objects. And you did the homework, but dog. Yeah, yeah. Used objects. Right. I believe you, mate. Plus 50 for saving you typing code. Alright then. I'm not doing 50 though. I'm not doing 50. No. We'll do that. There you go. There you go. For saving me typing time. Right. Let's sort this out. So pin 26. So we're gonna call it what did it call it? A light transistor or something? Photo transistor, isn't it? Now we'll call it light sensor. We'll use that. And that's on 26, isn't it? Yes. It's on 26. So this is at serial 1. That's why none of the things were coming through. Right, we don't need that. And we don't need that lot either, or that lot. Don't ask, don't get, yeah. Right, so, resolution. Ah, that was a point. Is it the same sort of thing? It will be, won't it? Because it's the Pico. Yeah. So we're going to change the resolution to 12. So 4096. So we're going to read the light sensor. So we're going to read the light sensor. And then what are we doing? Oh, just printing it out. Right, okay. So read the light sensor. And then serial.print reading. And then get rid of that. Now, what's the delay? What delay did they put on it? Did they put a delay on it? Oh, we'll put a delay on it. Right. So, let's reset this. Right, let's do it for real. Let's do it for real. Why are the buttons written in lowercase? Oh, I haven't reformatted this. I haven't reformatted it. Right, so we have numbers. Oh, it doesn't follow, does it? So I'm going to have to keep scrolling. Right, let's see. If I put my finger over it. Oh, hang on. So you can see what's going on. Right, there we go. So let's make this delay a bit longer. Let's make this delay a bit longer. There we go. Let's make the delay a little bit longer. Alright, FaiRLane. Thanks for joining. Now you've got C++ on pinch, you shouldn't need to keep putting into bootloader to upload code.
Oi, John, pay attention to chat.
I don't understand what you're saying, mate. Now you've got C++ on on Pico, you shouldn't need to keep putting the bootloader to upload code. Is that right? Right, here we go. So we're now on a lot slower rate, right? So 500 seems to be the norm. Just put my finger over it. There we go. 83 with my finger over it. Let go. That's 500. Where's my camera? Where's my phone? Right, let's stick the light on it. Wow, up to 3,000. I'll move away. Well, that didn't take long, did it? Right, that works. That works. I'm happy. That works. Right, what's the next activity? Right, so that was activity 1. Right, making light readings usable. Right, what we're going to do. This example takes the readings and turns it into a percentage. If it divides our readings by 655, well, that's going to be different for us. And then prints out. Okay. Is that activity 2? Yes, this is activity 2. Right. Rename. So we're taking our light sensor. Let's remember what's it doing. Right, light percentage. Okay. Equals reading divided by 4096. Because our number is between 0 and 4096, right? And then times it by 100. Right, okay. So, whoops. Don't want that. Times by 100. Then we're printing that one. Right. So you're saying I can just upload it? Yeah? Gary? You're saying I could just upload it? No. That's just running it, mate. That's just running the old one. Oh, it did not compile. Oh, it did not compile because we haven't... We didn't do that, did we? Try that again. Alright, I'll try it on the next one, yeah? See if it does it. What is going on? Oh, I know what's going on. Now do it. No, 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 no. Not that one. No, not that. Oh, I can't stop it now, can I? That one. John, it's C. Define it in line. I can't define it in there because it'll reset. Oh, I see what you mean. Hang on, I see what you mean. You're talking that, yeah? But I think because this loops round, I think it errors because it'll say it's already defined. It won't. Okay. I bow to superior intellect. Right. Let's put this back into what's it mode. Oh, it's still doing activity 1. Why is it doing activity 1? "27 years ago, I can't. I've had to get me university books out. Yeah, I know it's not in day 6. But I'm going to shut that down. I'm going to do that. It should then do this one. Right. Build. Why are you doing activity 1? Delete Arduino.json.
Oi, John, pay attention to chat.
I see it. I see it. Right. I see it. So every time, right, I see, okay. Right, this is testing. I haven't put it in bootloader mode. You're in Austria? Really? People ask you why you hate VS Code. This is not a VS Code issue, mate. This is the extension. This is the extension. So you're saying, because that's got activity 1 on, we're going to now put activity 2 up there, yeah? It's because of my workspace location. Okay. I like that one. Why is it doing it again? Well, that's not right. That's not right, is it? You said I'd get zeros. Why will I always get zeros? Change everything to float. But if we're getting an integer number divided by 4... okay. Okay. Yeah, okay. I see where you're coming from. That's integer. Divided by 496 would give us a decimal. Which would give us a float, and then we times it by 100, so... Okay. Yeah, less than 0. Or use floor. What's floor? Rounds down a value. If you round it down, it will always be 0, won't it? Really? That would work. That would work, would it? It keeps it an integer. Reading times 100, yes, still an integer. Divide by 496 would still be... Yeah. Well, you learn something new every day. You learn something new every day. Right, so it's running, right? Well, I never, right. So here we go. I'm going to put my hand over it. 6. And then I'm going to put my finger on top of it. 2%. Right? Right, let's try putting the... Oh, listen to it bing-bonging without resetting. Okay. Okay. Right. Let's put the light on it. It's getting bigger. Getting bigger. 94, 96. Will it have 98, 99? And I'm touching it at 99. Wow, okay. But that is something... Well, I never. You learn something every day. He's slacking off Android. needs 40495 to get 100. Yeah, yeah. I can see where you. I can see where you're coming from on that. Because it's 0 to 4095, isn't it? Yeah. Well, that works. Oh, I'm chuffed with that one. Right, let's put that into day 6. Let's make a copy. Rename it to 3. Let's go in here. Let's get rid of that. Right, what else we got to do? So that's our example 1. Example 2. Oh, here we go. Use the built-in round function. Alright, so this is where we convert it into a float, isn't it? Now, how do we do the rounding? Have we got rounding on C++? Okay, round. So we've definitely got a round. So they're saying use the round function to limit the decimal places to 1. Alright. Can we do that here? Yeah, but can we limit it to number of decimal places? Or is that a different one? Rounds x towards 0 to the nearest that's the nearest integer. Yeah, the round... Multiply by 10 and divide by 10. Would that work? Is it truncate? Because that says truncate at rounds x towards 0. Oh, I see what you mean. See what you mean. So we would Like that. Let's try that. Am I still doing it integer division? So if one of the numbers is an integer, it will just do it as an integer. Or is it just the numerator, not the division, not the divisor? If it really? Oh, he didn't like that. Oh, right, okay. Because that's an int and that's an int, it's doing an integer division. But that, because that'll be a real and that's an int, it'll do a real division. Yeah? Right. See, learning all stuff. The problem is in C#, I sort of cheat a bit. In C#, I sort of cheat a bit. Right, have you uploaded or not? No, you haven't. Right. Upload, because you didn't like the trunk. Really? 409.0 would be classed as a float. Now, that doesn't... Does that work in C# as well? Right. Right, how are we going to get any sort of numbers out of this? Right, serial monitor. Here we go. We got sync. Hey, look at that. Look at that. We got it. Yeah, I know, but I'm just, you know, I'm trying to compare C# with C++. Well, there we go. Sorted it. Now that was Andy, wasn't it? See, hashtag is Microsoft. Missing. I'm missing. Oh, sorry, mate. Right, okay, that's 2A. Right, okay. All this C++ that we're learning as well. Right, what's example 3? Well, that's just putting a percentage on the end. Oh, I'm not doing that. Right, light level indicator. Well, I code my primary language now is C# because that's what the company's moved to. It used to be VB.NET, but now they've moved to C#. And it's UI5 for SAP and Apex for Salesforce. Right, so next one. Activity, what's this? Activity 3. So this is light levels. Alright, okay. So it looks like we're copying this. So activity 3. Now we've still got the LEDs in place. So what are we doing? Right, so oh, okay. Right, okay. So we are doing this. Oh, I've got to sort this indenting out. Excuse me. Right. So if the light percentage is less than 30, then we are turning on the red. But we need to set the pins. Need to set the pins, John. Need to set the pins. Day 4. Right, so they're the pins set. So, which one's first? So, red is on. Right, so. Right, so let's copy this into there. Whoa. Right. Flight level is less than 30. Next one is 60. 60, then low, high, and then the last one will be low and then high. So if it's less than 30 it does that and then out, else if it's greater than 30, if it's less than 60 it does that, then out, if it's greater than 60 it does that. Right. Okay. See if that will knock this down to 100. This is not Pi-C. Oh, Iceman, thank you for showing. See Discord pic. When you next add the output, it will speed up build time. Like that. Alright. Right, let's pump this out. So activity 3. So if we're right, these 3 LEDs should change depending on what we're doing. Oh, big error. What on earth? Why is it doing all of them? It's doing all of them. Right, let's try this again. Activity 3. Come on. Why is it looking at active? Oh, stuff this. Oh, this is annoying. You can't nest projects. That's really annoying. Really annoying. So it builds all the INOs that's in the same folder. That's really annoying. Oh well, never mind. It's in the root now. It should work now. I suppose if you're doing classes and you're doing different files for each class, then I suppose. But it's annoying that it, even though you don't tell it to include, it's still trying to compile it. Right, come on. Let's see a light turn up. Right, red. Always red. Yeah. Hang on. Put the light on. Oh, there we go. Cool, that's a close. It's not much, is it? It's not much, is it? Flash the light. So there's not much in it, is there? It's just on the edge of the light, isn't it? There's a delay, but it's only 100 milliseconds, so it reacts straight away. Look, 100 milliseconds, so it reacts straight away. Oops, overlay. There. Imagine traffic lights that instantly turn green when your car light's close enough. Well, yeah, but it's, yeah. that would be interesting. Because then what? I suppose the closer one would take priority, but then it would always be on that lane if it was a very busy thing. All right, D-Type. See you later. Flash the light. Is right. Okay. So that's the end of day 6. So we've learnt how to make noises, and now we've learnt how to use the photo transistor. Now I was gonna set some homework, but I still will. Right. So the homework is to take your Pelican Crossing simulator and make sure it is one, and add the beeping, because the beeping happens when the green light's on solid, yeah? So if I go back to mine, right, if I go back to mine, right, so when we press the button and it goes white, yeah, when it goes green, so we'll let it so it's now stopping the traffic. Now it's gone green. This is where it beep 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 beeps. But then it stops beeping when the green light flashes. It stops the beeping, yeah. So now you know how to use the speaker, the buzzer. Add the beeping to your Pelican Crossing simulator, and make sure it does the Pelican Crossing, right? Right? Stop jumping ahead. Stop trying to jump ahead and be clever and stuff like that, right? Because on the next one, we're going to be talking about classes, because I want to start putting classes in, yeah. Now, and write it in functions. You know, make sure you utilize functions. I want to see a function for doing everything, yeah? Especially the things you do the most. Alright? So remember, we are still on the Pelican simulator. We're now adding the sound. So classic C++. Yeah, we're getting there. We're getting there. We're going to talk about classes. I'm going to try and explain classes. Spoil sport. Well, the thing is, the thing is, mate, I think in the because we can use this, right? On day 7, I think, because we're using the PIR sensor, I think we can use this in the simulator as well. And oh, it's not in here. It's not in here. Oh, that was annoying. So I'm going to have to think of something else. I think of a different homework setting that uses all this lot. Custom infrared brake beam sensor. What's that? So day 7, we'll use this in the. Well, I've nearly got the SDK working. I've nearly got the Pico SDK working. So when we can do it proper C, yeah. A security alarm sensor, yeah. But I've got the Pico. I've almost got the Pico SDK working, so we can write it in proper C++, yeah, instead of the Arduino help along. I mean, this is good for people who don't know the ins and outs of C++. But this is good. But I've almost got that one working. So this we can still improve the Pelican simulator with this, because I've got the idea for that, but I'm not sure what we could do with all this lot. This is where I'm going to have to read what they are so I can think of some sort of homework. I mean, custom waterproof temperature sensor. And what we're going to do with that? Fire alarm? Yeah, I suppose we could do a fire alarm. That it works on temperature rather than smoke. Ball tilt. Ooh, that could be a game. Yeah, that's what I was just thinking. That could be a game. Yeah, the tilt switch and the beam sensor could be a game. Yeah. And then this OLED. Yeah, we can. Temperature sensor tells John when his Pico's about to catch fire. I did think I'd broken it earlier, like I say, but I should have read the I should have read the manual on the breadboard. Right, so that's the homework. Right, homework. Add the sound, so it beep 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 beep, but it only beeps when the green light is solid. Once the green light starts flashing, the beep stops. Alright? Short circuit sensor. Right. So I hope you guys are having fun on the simulator, right? And the guys that have got the real hardware, I hope you guys are having fun. Because, like I say, I'm gonna try and on the next stream, I'm going to try and explain classes. I'm going to try, yeah, because the C++ classes is organized differently than the C# classes. So I've got to stop going into C# mode. But I'll try and do classes because I want to show that you can do a class and it can save a lot of time and effort. Will help. Well, thank you very much. Well, thank you. All right. So that's the homework. Is to slightly modify classes poor, slightly better off, well off politicians. And also, hang on. I want to check something. Stop. Do we have... Yes, we do. We do. I want to do something with this ultrasonic distance sensor. Even though it's not in the 12 days. We need to do something with that. You know. Like some sort of tape measure. You know, when you point it and it tells you how far away it is. Detect bats. Does it? But we'll look at that. Yeah. All right then, guys. Right. Well, thank you very much for joining. I hope this is entertaining because I've been asked to do a C++ project where we say convert Myriad or something like that. I'm trying to not be so adventurous. Maybe do asteroids or something in C++ and you know the SDL library as a sort of, you know, get to know. Unless you can detect the mouse, that would be hard to simulate. So I'm hoping that you're having fun. I'm enjoying this. I've never done electronics, right? And it frustrates the hell out of me because, yeah. But I'm learning. I'm also getting back into C++ and stuff like that. So, okay, guys. Right. I will say ta-ra for now because I'm gonna head on to the coast tomorrow to go to the holiday home. And try and close it down for winter. So I will see you in a couple of days, so we can do the next couple of days of the calendar. All right. Well, thank you very much, guys, and I will see you probably at the weekend. All right. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.